Good morning. In this class, we will study about one component system. Water is the best example of one component system. There are other systems, sulfur system, carbon dioxide system, we will study one by one. So water is the example of one component system. We will study here water system. Okay, now for water, for pure water, the component is 1. You know that it is very simple. Please listen carefully, you will understand completely. Okay, so for water, the component number of pure water, the component is equal to 1. Now let us consider minimum number of phase. Phase minimum, what is the main 1? 1 is the minimum number of phase. Therefore, let us apply now the phase rule we have studied earlier, the previous class. F equal to C minus P plus 2. Now you see, put C equal to 1, P equal to 1, then cancel 2. Therefore, there are two variables required. There are, for water system, there are two variables required to define the system completely. Okay, so this is the point here. So what are the variables required? Pressure and temperature. There are two variables. Pressure and temperature are required to define the system. Therefore, we plot pressure versus temperature. See, the plot of pressure versus temperature gives a diagram called phase diagram. The variation of pressure with respect to temperature is plotted. The curve obtained is called phase diagram. Okay. Now, water, there are three phases. As I told earlier, there are three phases. Water exists in ice, liquid, and vapor. Okay, you know that. Therefore, there are three phases. Very simple. There are three phases. Therefore, there are three equilibrium. There are three equilibria. What are the equilibria? Water in vapor. Okay, and ice and vapor, and liquid water and ice. Okay, so there are three equilibria. There are three curves. See, there are three curves corresponding to three equilibria. That's all. So you will now explain each curve. So this is about the one component system of water. Okay, there are three curves for three equilibria. Now let us explain the curve 1, OA curve. What is OA curve? In the OA curve, liquid water is in equilibrium. See, I have given. In OA curve, the liquid water is in equilibrium with the vapor. So this is heat of vaporization. This is called heat of vaporization. Now the vapor pressure curve of, this is the vapor pressure curve of water. Vapor pressure curve. This curve is also called vapor pressure curve of water. It gives the vapor pressure at different temperature. For example, at this temperature, what is the vapor pressure? At this temperature, what is the vapor pressure? So this curve is called vapor pressure curve of water. It gives the vapor pressure at different temperature. It gives the vapor pressure. This is vapor pressure at a different temperature. At different temperature, what is the vapor pressure? So for each temperature, for example, at 100 degrees Celsius, there is one vapor pressure. Listen carefully. For each temperature, there will be one and only vapor pressure, or vice versa. For one vapor pressure, there will be one temperature. Okay, so you can write in both the way. Next, let us apply the phase rule. That's all. Next, we will apply the phase rule to this equilibrium curve. F equal to C minus P plus 2. So, number of component 1. One component system. There are two phases. And plus 2. Therefore, it is equal to 1. Okay. So, it is a monovariant. This is a monovariant curve. During the curve, the system is monovariant. Okay, because it depends only upon the only one variable. Okay, now at the next point, at 100 degrees Celsius, for example, at 100 degrees Celsius, the vapor pressure is equal to 1 atmospheric pressure. That is called the boiling point. You know what is the boiling point of water? 100 degrees Celsius. At 100 degrees Celsius, at boiling point, the vapor pressure, for example, if you increase the temperature, the vapor pressure will increase. When you increase the temperature, the vapor pressure will increase. At boiling point, the vapor pressure is equal to atmospheric pressure. This is the atmospheric pressure. That is P1 equal to, the vapor pressure is equal to atmospheric pressure. That is the definition of boiling point. Okay. Now the curve extends up to, for example, the curve extends up to A, that is 374 degrees Celsius. The curve extends up to 374 degrees Celsius, called critical temperature. This temperature is called critical temperature. Why? Because above this water will be completely converted into gas, vapor. No liquid exists. Therefore, at above this point, for example, at this 100 degree, water is converting slowly into vapor. Above this point, it is in the gaseous phase. It is in the vapor phase. No liquid exists. Okay. So now the variation of vapor pressure, with respect to increasing temperature. The variation of vapor pressure with respect to increasing. We are increasing the temperature and we are measuring the vapor pressure. So the change of vapor pressure with respect to temperature is quantitatively derived. The expression for this curve is quantitatively derived by Clausius and CLAYPERON. Okay, it is for equilibrium process, equilibrium reactions. Clausius CLAYPERON equation is used for equilibrium process. This is the differential form. The change of vapor pressure with respect to temperature. Change of vapor pressure. dP means change of vapor pressure with respect to temperature is equal to delta Hv by T Vg minus Vl. What is Vg? Vg is the volume of 1 mole of vapor. Volume of 1 mole of vapor, and Vl is the volume of 1 mole of liquid. This is the delta Hv is the heat of vaporization. Of liquid to vapor. This is known. Okay, now on integration, this is the integrated form of Clausius-Clapeyron equation. What is the integrated form? On integrating this equation, you will get ln P2 by P1 equal to delta Hv by R 1 by T1 minus 1 by T2. Okay, this is similar to your Arrhenius equation. Everybody knows Arrhenius equation. Log K2 by K1 equal to Ea by R 1 by T1 minus 1 by T2. Okay, here for example, one temperature, or this temperature I am heating. For this temperature, the vapor pressure is P1. Okay, and for I am heating, effect of temperature. On heating, the temperature is P2. Now the vapor pressure is P2. Now you can calculate delta Hv by using this equation, or if you know this, you can calculate P1 or P2 or T1 or T2, etc. Okay, now let us come to OB curve, this curve. OB curve. In this curve, ice is in equilibrium with vapor. You see, OB curve, the ice is in equilibrium with vapor. Therefore, this is called vapor pressure curve of ice. This is vapor pressure curve of water. This is the vapor pressure curve of ice. Okay, this curve is called this OB curve. And the lower end, here the upper end, here the lower end extends to absolute 0 Kelvin. This is absolute 0 Kelvin. This point is called 0 Kelvin. That is minus 273. The lower end extends up to 0 Kelvin, minus 273 Kelvin. Same as for each temperature. For example, for this temperature, there will be only one vapor pressure. This temperature, there will be only one vapor pressure. For each temperature, there will be only vapor pressure. Similarly, for this vapor pressure, there will be one temperature, or vice versa. Therefore, by applying the phase rule, same, you can write here also, F equal to C minus P plus 2, 1. F equal to, the degree of freedom is equal to 1. Therefore, this is monovariant process. Okay, now, the effect of temperature on the vapor pressure curve of ice, okay, is given by, again, Clausius-Clapeyron equation, dP by dt delta Hs. In this case, heat of sublimation. Ice is, the solid is converted into gas. That is called sublimation. You have studied what is sublimation. In sublimation, solid is directly converted. For example, iodine solid is directly converted into gas, vapor. Okay, so therefore delta Hs heat of sublimation of water, T Vg minus Vs, because Vg, this is not Vg, this is Vg only, right? Vg minus volume of vapor, volume of 1 mole of vapor, right? And volume of 1 mole of ice. Volume of 1 mole of vapor minus volume of 1 mole of ice. And the integrated form for this curve, integrated form for this curve of Clausius Clapeyron equation is ln P2 by P1 delta Hs, here delta Hb, here delta Hs, or I am written this cross multiplying this T2 minus T1 divided by T1 into T2 mathematical step. Next, the important one is the point O. What is the point O is called a triple point. What is triple point? What is triple point? At triple point, if you look at vapor phase, ice, liquid water, there are three phases existing in equilibrium with each other. See, at triple point, at a point O, the three phases coexist. The three phases are in equilibrium, called triple point. This point is triple point because there are three phases which are existing together. Okay, at triple point, the temperature is, so you know the triple point. What is the temperature here? You can find the temperature equal to 0.0075 degrees Celsius. And the corresponding vapor pressure is this. What is the corresponding vapor pressure at triple point? So they will ask, what is the temperature of triple point? What is the vapor pressure at triple point? So the vapor pressure is 4.58 millimeter mercury. 760 millimeter mercury is 1 atmospheric pressure. Okay. So next, let us apply the phase rule for this point. Let us apply phase rule. F equal to C minus P plus 2. Therefore, number of component 1, there are 3 phases, and plus 2, therefore equal to 0. More the number of phases, then the lesser the degrees of freedom. Smaller the degrees of freedom. In the previous class we have seen. So it is if F equal to 0, then it is invariant system or invariant point. This is a point. Therefore, this is an invariant triple point. They may ask in competitive examination, triple point is invariant, bivariant, univariant. Therefore, triple point, it is called invariant point. Next, come to OC curve, final curve, OC curve. In the OC curve, ice is in equilibrium with the liquid water. In OC curve, the ice is in equilibrium with the water, liquid water. This curve is called fusion curve of ice or melting curve of ice. Melting. In the curve and the melting of ice, here, this curve is called fusion curve of ice because it gives the effect of pressure on the melting point of ice. If you increase the pressure, what happens? The temperature decreases. This side, it moves this side. Now here, increase the temperature, pressure will increase. But here, if you increase the pressure, you are increasing the pressure, therefore the temperature decreases. Therefore, increase of pressure decreases the melting point. This curve gives the effect of pressure on the melting point curve. Therefore, effect of pressure on the melting point, and increase of pressure decreases the melting point. Increase of pressure decreases the melting point. Let us now apply the Clausius-Clapeyron equation for this equilibrium. For this equilibrium, we can apply the Clausius-Clapeyron equation. dP by dt equal to delta H of heat of fusion. This is the heat of melting or heat of fusion divided by T dl minus volume of 1 mole of liquid minus volume of 1 mole of ice. 1 mole of ice. If you look at that volume of, if you put ice into water, will it float or will submerge? Will go down? The ice will float. Why ice will float? Because the density of ice is less than water. That means volume of ice is greater than volume of liquid. Volume of ice is greater than liquid. If volume of ice is greater, this is greater. Therefore, it will be minus sign. Therefore, dP by dt will be a negative value. That's why increase of pressure decreases the melting point. Increase of pressure. Whereas here, increase of temperature increases the vapor pressure. Here, increase of pressure decreases the melting point. Because of this, dP by dt is negative. Okay. So, if you, for example, you are keeping a water bottle in fridge. Do you fill it with water or little bit less water? If you fill it full of water, what will happen is at the freezing point, if you in the freezer, it will freeze. So it will expand. The volume of ice is greater. Than liquid. The bottle will break. So you don't keep pour full of water because of it is already known. Therefore, volume of ice is greater than volume of liquid. Okay. So there are several questions For example, even in GATE, CSIR, they ask based on this, and there are several questions. What is triple point? At triple point, it is what is the degrees of how many degrees of freedom? So please understand very carefully, and then only you can answer. Otherwise, you will not be able to answer. Thank you for watching.